the technical details of Coffea-Casa and what it takes to actually run one of these facilities, and a little bit into what we're trying to satisfy with Coffea-Casa, what we're trying to build with Coffea-Casa, and how we're trying to roll it out. I, of course,
sorry to interrupt.
Yes.
At the right side of your screen, there's like a black box that is exactly there where your mouse is, like slightly occupying the screen space.
There.
Okay, perfect.
Better?
Yeah, perfect.
Zoom.
Thanks.
After a year, you'd think I'd be better at Zoom. I, of course, am not alone in the Coffea-Casa project. Matter of fact, I feel like I'm sort of the least important man out of the group in front of you. The heavy lifting is done by Oksana and Garen and John in our facility, and Brian and Ken are sort of the dynamic leads, and Matt does an incredible amount of testing and tutorials for us. If you've seen a Coffea-Casa talk before, we've talked a bit about what we're trying to satisfy with the Coffea-Casa platform. And this slide I pulled directly out of an earlier talk, and I thought it would be an excellent outline for today's talk. When we designed Coffea-Casa, we really wanted to utilize some very modern tools. We wanted to use modern authentication. We didn't want to use grid. We didn't want to use X509. We wanted to leverage a lot of the new data delivery technologies that are coming on the scene. But mostly we wanted to support the columnar analysis and support the new Pythonic ecosystem. And I'm not going to talk very much about that today because I think you've been getting that, fire hose to your face most of the workshop. So I'm going to put that off to the side. We also want to, take advantage of modern deployment techniques and integration techniques. I'll talk a little bit about those. We wanted some support for object storage. Again, this is more of that data delivery service. We'll bump that up there. And we wanted it to easily integrate with the current HPC and HTC resources on the floor. The way I really see Coffea-Casa is the site's effort, our site's effort, to deliver the new tools to our users. So I mean that up a little bit here. And the outline for today's talk is showing how we're trying to get these tools into everybody's hands. Again, if you've sat in a Coffea-Casa talk before, you've seen this particular slide. This is what I would characterize as the current deployment on the floor at the University of Nebraska. The idea here is we want a browser interface to our users to come in and get a Jupyter Hub notebook instance, or a Jupyter Notebook instance from our Jupyter Hub, which in tandem to giving them the Jupyter Notebook spins up a small pod of Dask resources. That pod in itself is a Dask scheduler, a couple of workers that are placed in the Kubernetes resource, and so they're immediately available. And then their scaling abilities out to the tier 2. The Nebraska tier 2 facility has been, we were one of the original US tier 2s when the tier 2 project came online. And we have a large platform of analysis hardware on the floor that CMS owns. And it's going to be a CMS sort of flavored talk. The CMS resources, though, are not locked behind, but accessible only through the grid. And the grid is not a great platform for doing interactive research. The grid is a great platform for getting a lot of highly efficient jobs through. But in terms of the turnaround time from when I submit jobs to when my data comes back and I have insight on what my data is telling me can be quite long and quite frustrating. Okay, a lot of people talk about the time to insight. Our phrase here at Holland is time to science. The amount of time it takes you to turn around your analysis to start doing useful science can be quite long. What we'd like to have is a more interactive approach, and so the idea of the Coffea-Casa platform was born. Integrated into the platform here at Nebraska is also Service X, Skyhook, and an Xcache service, and I'll talk about those a little bit. Although my experience with Skyhook is very small, and my understanding of Service X is a little not great. That's Oksana's bailiwick. But I really don't want to run the only Coffea-Casa on the planet. That was never the idea behind developing one of these things. What we would like to do is for people to be able to remotely stand up their own Coffea-Casa instance on their own platforms and their own institutions. So that raises the question then, what exactly is Coffea-Casa? What are we responsible for? What are the other users and adopters really responsible for? The core of Coffea-Casa, the real pieces of it that I think are the heart and soul of the platform are really the base images, which incorporate all the Pythonic tool sets, the Coffea analysis framework, a Dask scheduler, I think that is part of the core. Web-based authentication is part of the core. Parallel processing is part of the core, and of course JupyterHub is part of the core. Luckily, a lot of that we've inherited from other projects. Certainly, Zero to JupyterHub project was a way for us to quickly get a stand-up framework in which to start plugging into it the HEP centric aspects of Coffea-Casa. And we hope, although I think some of these are still pretty tightly coupled to the core, we'd hope for those to be plug-in like in nature. We'd like people to be able to design a plugin that they could bring on board to their own Coffea-Casa instance and have it integrate, at least with a minimum of effort. The plugins that we've outlined and identified, of course, are Xcache, the Condor scale out, which is tightly integrated here at Nebraska, but that's really not something that's crucial. It could also be a Kubernetes scale out. And I would love to see the day when my compute here at Nebraska is less Condor flavored and more Kubernetes flavored, with Condor being the scheduler and Kubernetes being the engine. That would, alleviate a lot of the headaches that I have when dealing with Kubernetes if Kubernetes was aware of everything. We've also got CVMFS deployed. That was a little tricky at times, but a lot of work has been done with getting CVMFS working on Kubernetes, certainly at the Open Science Grid, and I followed their recipes for getting that available, but it's not necessary. It's a plugin, really. We've got other plugins that we're working on, and we imagine, including like Binder Hub and WorkQ. WorkQ is another what I would call a call and response clustering tool set, where a worker spins up, announces its presence to a manager, and the manager sends it work. We would love to integrate WorkQ. That's a product that I don't know if it's from Notre Dame, but they use it extensively with their HTTP services, and we'd love to get that integrated. So authentication tools, if you were to spin up your own Coffea-Casa instance, there's a lot of groundwork that you have to lay in order to have it really function and behave like Coffea-Casa at Nebraska or Coffea-Casa in Chicago. And one of the things you're going to have to do is register the system with some sort of authentication toolkit or front end, right? There is dummy authentication available inside of JupyterHub, and we use it extensively for testing and for spinning up instances that really aren't official or aren't persistent or going to live very long. The dummy authentication is very useful, but in order to slip from testing over into production, you're really going to want to have a more official front end. I've been with the tier 2 long enough that I remember the early discussions of the tier 2s. One of the hard lines we drew in the sand at that time was user management. We were never going to do user management. It was not something we wanted to handle. And as somebody who approves the accounts for US CMS Connect, for instance, it's still fraught. It's fraught with dangers for opportunities for people to take advantage of the naivety of somebody approving accounts. And we wanted to avoid that, us being the weak link in doing the account management. That philosophy stuck with me. I don't want us doing account management at Coffea-Casa, and I don't think anyone else really should if they're offering it to more than a handful of people. But we use the OIDC instance at CERN. It integrates into the CMS database, and so if I use this, I'm fairly well I'm pretty confident that any user that's able to authenticate against the service has been vetted by CERN and is listed in the database as being part of CMS. And that's one less thing I have to worry about. In order to really register with this instance, it's actually pretty easy to register with the instance. If you go to the OID page and take off the trailing dashboard stuff that has to do with your account. See, I'm logged in here as C1, so it knows who I am. It's pretty easy to go in and do a self-service registration for a client. And of course, it forgot who I was. The interface is quite simple. Oh boy, all the things, right? The interface is actually quite simple for a new client. You're gonna have to tell it where to call back to here in this redirect URLs. You don't really need logos or any of this good stuff. The real things that are important is understanding which of these are important, which of the callback and response. Certainly we want the WLCD groups. We're going to want a refresh token so that you can auto refresh the tokens. And we're going to want a collection of these. When you register for a new service, you'll get a client ID, a client secret, and a registration access token. Although it sort of remembers who I am and that certain instances belong to me, I'm not the only person managing Coffea-Casa. And sometimes we need to change some of the access protocols or what's returned with the thing. And so we would like to have other admins able to administrate our registration. If you come in with the registration access token and the client ID, you're allowed to change these things. What that means in Coffea-Casa is I have to supply a Coffea-Casa with this client ID and this client secret. And so this is one of the headaches and what I've come to call the pain points of deploying a Coffea-Casa instance is the secret management. And here's a screenshot of the OIDC that I had taken in case when I knew things would go wrong, which show some of the settings we have here in Nebraska, the redirected URLs so that it knows that it's talking to the correct ID. And in the open data instance, we only need a CI logon instance, but there's lots of people with CI logon instances, but we only have allowed groups. The group allowed for the thing is restricted to people who are actually allowed to use the open data facility. The pain point here is managing the secrets, and deploying the secrets into Kubernetes is relatively easy to do. I would say it's tricky to manage. When we first spun up the thing, I was launching secrets into the Kubernetes instance. Kubernetes instance was storing those, and then I was forgetting how I'd done them or what each of them meant. Oksana would need access to a particular secret. I wouldn't know exactly how to give her access to that. And it was a pain. And certainly it wasn't something I wanted to manage by hand. And so now we seal them up. We use a third-party package called Bitnami's kubectl. Kubectl encrypts the secrets. Here I'm able to show you a screenshot with my secrets here because they're all encrypted. And that allows me to check those secrets into Git. If I then have the keys to the encryption algorithm, I can unlock these and see what they look like, put them into web forms and manage the system as needed. Where's the key stored? This key is only stored deep in the bowels of Kubernetes. Kubernetes has the key, and when it signs a particular secret, it signs it not only with the key, but also with the namespace in which that key resides. And so I can't cross-contaminate my secrets across two namespaces and expose them. I can't spin up some random instance in Kubernetes and seize everybody else's secrets with the Kubernetes kubectl key. So that's pretty useful. This allows me to check these things into Git and not worry about them being compromised. So the two important things here are the ID and the secret, but I also checked in the client's access key. And that way, if Oksana needs to manage the instance, she can go to the Kubernetes instance, open up that secret in the namespace and have it exposed as plain text, grab it and drop it into their web browser and manage that instance. We do a lot of token management at Coffea-Casa. Here again, we wanted to utilize and get away, utilize modern authentication techniques and get away from X509. And really, I think it's not that X509 is a particularly bad bad way of doing things. It seems just a little onerous. It's a little tougher for a lot of users to manage those things, and it's also something you don't want to be, passing around lightheartedly. X509, your X509 certificate is basically you. When I look at an X509 proxy, I give that proxy all the privileges that I would give you. A token works a little bit differently in that a token acts as a permission to do particular things, and so I can limit the scope of a token in ways that I can't limit the scope of a proxy. Even with VOMS proxy extensions allowing me to identify a little bit of the role in which the X509 proxy is behaving, it's not as limited as what I can do with tokens, and it's not as dynamic as tokens. The token management inside of Coffea-Casa, I think the two big players are HD Condor and Xcash. I will say that Xcash access does have some X509 stuff on the back end, but we did our best to obscure that from the user. And as the tokens, side tokens interfaces and the side token adoption gets a little bit more mature, and my understanding of it gets a little bit firmer in my head, we're going to tear that out and we're going to replace that with proper side token access. What I've seen here is the sample Xcash payload token, shows what CMS Jovian, which is the user that you experience when you're on Coffea-Casa, is allowed to download out of store, and, as long as it hasn't expired. One of the confusions in my head, and it continues to be a confusion across the tier 3s, and I try and help them understand the distinction, is the difference between Condor's pool password and Condor tokens. We use Condor tokens in Coffea-Casa because the Condor pool password is the master key for your cluster that allows people to submit jobs. It allows them to act as daemons, to change policies, to do all kinds of crazy stuff that you really don't want people doing in your Condor pool. Tokens, however, again, limited. You can say this token is allowed to submit jobs. This token is allowed to receive jobs if it's a computer that's passing the token. When you log into Coffea-Casa, the pool password for our submit node is actually in Kubernetes, but you will never see it. It's obscured again from the user. What happens is that pool password is used to sign your token, which is then dropped into the user environment, allowing you to submit jobs into Condor and do the scale outs. Okay, I can revoke those tokens at any time. I can also close up shop pretty quickly by limiting their scope. Okay, by saying, hey, any token with CMS Jovian involved is no longer allowed to play. Other building blocks in Coffea-Casa. Right now, the plugin for Xcash at Coffea-Casa is actually an external service running on Red Xcash 1. It's along with a lot of the current deploy for Coffea-Casa's older hardware we had laying around that wasn't serving a useful purpose at the time. Red Xcash 1 has 88 terabytes of cache space and allows CMS Coffea users access to CMS data namespace. Ideally, we'd love to replace Xcash, an Xcash external service like this with a plugin inside of Kubernetes, and a lot of work's been done. I know I owe Bert an apology because I know he's done some work getting charts built up for Xcash, and I haven't worked through those yet and got them vetted and tested and make sure that they work. But we'd like Xcash to be part of the deployment itself and not something you stand up alongside and have ready to go. We'd like that that spin up and tear down to be part of the process of deploying Coffea-Casa. Okay, I would say that the full Kubernetes native Xcash is almost there, and I'm certain that other experts can spin it up trivially, but getting it integrated into the packages is a little bit different. We've also deployed a little bit of Skyhook. My only comments about Skyhook is we're bumping into a limitation of Skyhook, and the Skyhook being built off of Ceph and Ceph block systems requires direct access to the Ceph underlying file system, and that doesn't easily cross network boundaries. And whether I could do this with some sort of Raddus gateway or whatever is beside the point. Right now, it's limited, and so if I spin up to Condor, those worker nodes cross a network boundary and are not able to talk to Skyhook. And so our Skyhook instances are limited to the resources that we can provide inside of Kubernetes. Other building blocks, Dask. Why Dask? And this is a question that I asked early on, is why Dask? There's a great deal of work going on trying to do similar tasks with Spark at the time. Spark was a leading candidate for a long time for what we were going to be able to parallelize these tasks for. And Dask, I think, was an easy button. Dask works integrates so easily into a Pythonic environment, just working. Spark, I saw a lot of incredibly intelligent people doing a lot of hard work, and that's very dangerous to me. I see that and I get very scared, because I'm neither super intelligent or super hardworking, and if they're having troubles, I know it'll be a struggle for me as well. Dask provides a nice task management computational framework. I would call this, again, a call and response scheduler. The scheduler has tasks. The workers call in and say, I'm available for work. The scheduler gives out work. What the scheduler is not, it is not a multi-user facility like scheduler like Condor. The scheduler has no awareness of what multi-user is. It just has a list of tasks. And so integrating it into a multi-user environment is a little bit tricky. It certainly, at least now it is. Whether that'll change in the near future, we'll see. But we spin up a scheduler for every single user in Coffea-Casa, a Dask scheduler. And then the Dask workers, we spin up a couple of Dask workers inside of Kubernetes. And when things scale out, those workers appear in the Condor pool. As far as implementing Dask in Coffea-Casa, here the big key here is there's a network boundary. Again, the Condor systems, the tier 2 system, stands up on its own, and it has its own day job. It has a day job of being a tier 2 for CMS and providing resources for the grid. I can't readily mess around with its networking in good conscience unless I can do it really, really well. So what the Dask scheduler has to do is when it spins up and starts looking for other workers, those workers have to have an address to call back to. Of course, the Dask scheduler lives inside of pod, inside of Kubernetes. Kubernetes is very good about exposing pods to an ingress service, allowing connectivity. And so we configure something called traffic to manage that ingress. It stands up an ingress into the Dask scheduler. It tags that address into the user's environment. The environment gets passed along with the job. When the job spins up the container running the Dask worker, that Dask worker's execution script contains that address that calls back out to the Dask scheduler inside of Kubernetes. Okay. So how we do that? Well, it has its own address, and we have to, have a DNS entry. And that DNS entry is, so if you're spinning up a Coffea-Casa, notice my Coffea-Casa eats 2 IP addresses, one for the hub and notebooks, one for all the little subsequent services. Here we're implementing Dask in Coffea-Casa. One of the big strengths of Coffea-Casa, and one of the core elements, when I showed the core elements for Coffea-Casa, is we're trying to obscure a lot of these details from the users. That obfuscation is a core tenet of Coffea-Casa. Here, what we're doing is we're leveraging Dask's job. Well, it's actually a modified version of Dask's job queue extension to automatically configure that environment. And so the user doesn't need to know anything about the tier 3 config or the tier 2 configuration. It doesn't have to know how much memory to request in a job slot. It doesn't care how many cores we do all that at the front end. However, if you're going to deploy a Coffea-Casa, these are decisions that you have to make. And how comfortable are you giving out 6 GB per slot for these Dask workers? Notice it's 2 cores, so it's 3 GB a core, but it's still 6 GB is not a trivial amount of RAM, especially in today's market. Those things are stuff that you have to think about as you're deploying a Coffea-Casa. What is Coffea-Casa doing on the back end that you may not be aware of because we've obfuscated it from the user? Sysadmins, although they enjoy having users having a good time, they also need to know what's going on in their system and what decisions have been made on their behalf inside the configs. And so that code, of course, is available, but you have to know what that code is doing to really understand to look for it. In terms of modern operational models for Coffea-Casa, when we first spun it up, we spun it up on Iron. It wasn't in Kubernetes. That was a nightmare. And just with two of us administering it, we were always falling all over each other. We moved to Kubernetes. That didn't make things easier. If you've ever worked with Kubernetes, Kubernetes works from a command line interface from sort of anywhere, as long as you have the keys. And so it's very easy to trip across what each other is doing. A much better model is using GitOps and Flux. Flux is a service we spun up on the Kubernetes, and it takes the Kubernetes ideal of cluster state as a operational model. Flux has a set of conditions. It looks at the state of the cluster and it tries to make the two match. Flux can also take the Git repository as a source for that state. And so thus is born that concept of GitOps. What I do is I push my state into Git. Flux pulls that state out of Git and then applies it to the cluster. And it's just that easy. No more do you do kube control apply. What you do is you commit the code to Git. We're still tripping across each other because I'm terrible at Git some days, but it's a much better way of documenting what changes have been made. And I can read in the Git repository what I think the state of the cluster should be, and again, what decisions have been made on the back end. Further extensions and improvements for Casa, things we'd like to do in the future. As I mentioned before, I'd really like Xcache to be part of the Kubernetes deploy and not a stand-up service that's standing alongside. I'd really love to work on Kubernetes scale out. I would love to get as much of Coffea-Casa's functionality underneath the Kubernetes hood as I could. That probably means working with something like Kueue, or something of that nature, where Kubernetes finally gets a more dynamic multi-tenant type scheduler. I don't know what that's going to look like, but I'm excited to find out. Once I have more Kubernetes scale out, that allows for an improvement in Skyhook. It allows Skyhook to be more easily adopted. We'd like to move to Binder Hub. Binder Hub is a way of sharing user environments. Many of you are very familiar with Binder Hub. I'm not so much, but anything we can do to make the user experience more palatable and easier to adopt, the better. I'm certainly trying to get work queue working on the back end of Coffea-Casa so that we can utilize some excellent work that's been done there for work queue does interesting things like making sure environments are consistent, making sure that libraries are the same version and so forth in each individual worker, making sure that their state is correct before it attempts to run a job. And lastly, accounting. One of the big things that I put forth when we first started doing this is how are we going to take credit for the work done by Coffea-Casa? When Coffea-Casa dumps into the tier 2 and the tier 2 does core work, Condor keeps track of that, but the WLCG might not know about that, and that effort really needs accounted for. And that's something we've brought on personnel to work on accounting, and I'm hoping maybe I can get a student worker maybe to help us out with better accounting. Also, I'd like to have a better example of Casa in Minikube. We have somebody who's working on that very hard and has been able to do it, but I still think it takes a lot of technical acumen to get Casa running in Minikube. I think once Casa is running in Minikube, that will be a statement on how easy it is to deploy on a cloud resource or at a site. We use, of course, Jupyter Hub's we use a lot of management tools to manage it. Jupyter Hub allows me to manage some of my user instances. It's very rudimentary. At least the "it worked for me" argument goes away when I can log in as another user and see exactly what they're seeing. And finally, we also use Lens. Lens is a graphical interface for Kubernetes. It shows me pods, it shows me resources, it shows me a great deal of the state of the cluster. It allows me to nuke pods, to log into containers and see what's going on. Lens has been incredibly useful for Coffea-Casa administration. And so if you're thinking about running a Kubernetes resource, step 2 is get Lens. So I'll stop there. Hopefully I haven't wildly bored you out, or at least said some things that might have been useful or interesting. And I'll take questions if you have them. I see there's 9 chat things, but I was scared to bring up my chat window, 10 chat things. Alex, do I have questions?
Great. Yes. Thanks a lot, Carl, for talking us through the details here. It's very interesting to see what is all happening behind the scenes when sort of as a user, I just log in and things are running. So thanks a lot for providing those details. We have a few questions in the chat. Sure. Let's take some of those. Doug, I see you had 2. Would you just like to ask them, or otherwise I can read them as well from the chat? Okay, let me start with the first one that was in the chat, which was, I think, about CPU and GPU, right? Does Coffea-Casa understand CPU only and CPU GPU nodes?
Currently, it only understands CPU. We have purchased a GPU in our next deploy, which we're migrating to as soon as we're done with the grand challenge here, and we can introduce a little instability. We're moving over to our new hardware with GPU. The GPU awareness, I'm not sure how I'm going to fold that in, what that's going to look like, but we're certainly it's something we wanted to do over the past few months and haven't gotten to yet. Right now, it's only CPU aware, but GPU is something we're going to work on very quickly, very soon.
Okay, thanks. And there was another one, I think, also from Doug. How many of the plugins are non-service? How do multiple Xcache Kubernetes pods share data to avoid multiple copies of the same data on disk?
So Xcache, I mean, the point of Xcache is to actually duplicate data on disk, right? That's the idea, is to create data locality. So Xcache, avoiding data duplicity is not something I think I can understand how to do with Xcache.